Okay, let's pick back up with number 18. A geometric sequence is defined by using the following rule. I find this one interesting. You've got the recursive formula, and the takeaway for this recursive formula is we're multiplying by -2. I like using the geometric formula, using the first term, which is interesting that it's starting with 0 here. So if I start with 0, my first term is 4. I multiply by -2, and the next one would be -8. I multiply by -2 again, and I will get, if you want to make it into a box, that would give me a +16. Multiply by -2 again, oops, you can't see it, I'm sorry, -32, and then for the fourth term, multiply by -2, and you get a +64. So my answer is 64. Now, if I'm using the geometric sequence on this, I'm going to use my first term, which is 4, and multiply by -2. A couple of ways you can look at this. My first term really isn't 4. My first term is -8. So I really need to use, no, I'm sorry, it is 4. However, if this is my first, second, third, fourth, this is actually my fifth term, so you would use n minus 1, and actually you wouldn't use n minus 1, you would just use n, which is a little tricky. That's why I like using that chart right here. So it would be 4 times -2 to the 4th power, because this is actually the 5th term in the sequence. So that's why you do 5 minus 1. So it's a little tricky there on that one. On 19, which is larger, the 10th term in the arithmetic sequence that begins with 0 and 100, or the 10th term of the geometric sequence that begins with terms 5 and 10? Show your work that justifies your answer. All right, so arithmetic, we're looking for the 10th term, but we're starting out terms 0 and 100. And so if I'm going to use the arithmetic formula, I'm going to use, let's see, my first term would be 0. And I think they tell me that the